The vastness of the universe far exceeds imagination. From microscopic interstellar dust to galaxy clusters spanning tens of billions of light-years, celestial bodies of various forms and patterns collectively weave this magnificent stellar tapestry. They either emit constant light and heat or conceal extreme physical laws, each carrying the codes of cosmic evolution while guiding humanity's footsteps into the unknown. Stars are the most common and fundamental luminous objects in the universe, serving as the basic units of galaxies. The nuclear fusion reactions in their cores are primary source of cosmic energy. A star's birth begins with the gravitational collapse of an interstellar molecular cloud, when giant clouds of gas and dust are disturbed by supernova shockwaves or galactic collisions. Denser regions contract under gravity, causing temperature and pressure to rise until hydrogen fusion ignites in the core, marking the birth of a new star. This phase, known as the main sequence, is the most stable period in a star's life. Our Sun, currently in this stage, has been burning steadily for 4.6 billion years and will continue for another 5 billion, from birth to death. A star's life follows the rule that mass determines fate. Low-mass stars, less than 8 times the mass of the Sun, like our Sun, evolve most gently. After exhausting their core hydrogen fuel, their outer layers expand into red giants due to gravitational imbalance, swelling to hundreds or even thousands of times their original size. The core then contracts and heats up, initiating helium fusion. When helium is depleted, low-mass stars cannot fuse heavier elements. Their outer layers drift away, forming planetary nebulae among the most beautiful objects in the universe, such as the Cat's Eye Nebula and the Ring Nebula, whose complex structures result from interactions between ejected material and the interstellar medium. The core leaves behind an extremely dense white dwarf, Earth-size, but with a mass about 0.6 times that of the Sun, no longer generating energy. It glows only from residual heat, eventually cooling over hundreds of billions of years into a dark black dwarf. Though the universe's current age, approximately 13.8 billion years, is too short for any to have formed yet. Medium-mass stars 8 to 30 solar masses meet a more violent end. When core fusion produces iron, which absorbs rather than releases energy, the core collapses catastrophically under gravity. A powerful shockwave rebounds outward, tearing the star apart in a supernova explosion, one of the universe's most violent events, briefly outshining entire galaxies for weeks or months. The guest star observed by Chinese astronomers in 1054 AD was a supernova, whose remnant now forms the Crab Nebula. If the remaining core mass is between 1.4 and 3 solar masses, it collapses into a neutron star, the densest known object besides black holes. A single cubic centimeter of neutron star material weighs 800 million to 2 billion tons, equivalent to compressing Mount Everest into a sugar cube. These stars, only 10 to 20 kilometers in diameter, can rotate hundreds of times per second. Some, with immensely strong magnetic fields, accelerate charged particles into beams of radiation. When these beams sweep past Earth, they are detected as regular pulses, earning them the name pulsars. Their clock-like precision once led scientists to speculate about extraterrestrial origins. High-mass stars over 30 solar masses meet an even more dramatic fate. After a supernova, if the core's gravity overcomes neutron degeneracy pressure, all matter collapses infinitely into a singularity of zero volume and infinite density, surrounded by an event horizon from which not even light can escape, a black hole. In some extreme cases, massive stars may collapse directly into black holes without a supernova, a phenomenon termed failed supernovae that astronomers have observed. Compact objects, the end products of stellar evolution, exhibit physics beyond everyday experience and serve as natural laboratories for testing theories like general relativity. Beyond extreme density and rotation, some neutron stars become magnetars, with magnetic fields 1,000 times stronger than ordinary neutron stars, over 1 trillion times Earth's field. These can trigger violent starquakes. 1 in 2004 released more energy in 0.2 seconds than the Sun emits in 50,000 years, disturbing Earth's ionosphere. In 2017, the first detection of gravitational waves from merging neutron stars, accompanied by electromagnetic signals, confirm that such events produce heavy elements like gold and platinum, solving the long-standing mystery of the origin of over half the universe's heavy elements. Black holes remain the most enigmatic celestial objects, their central singularity shrouded by the event horizon, beyond which nothing, not even light, can escape, and spacetime is profoundly distorted. They are categorized by mass. Stellar mass: black holes 3 to 100 solar masses. From collapsed stars. Intermediate mass: black holes 100 to 100,000 solar masses, possibly from mergers or direct gas cloud collapse, with candidates found in globular clusters, and supermassive black holes millions to billions of solar masses, residing at the centers of most galaxies. Contrary to the image of absolute darkness, supermassive black holes are often intensely bright. Gas and dust pulled into their accretion disks swirl at near-light speeds, heating to tens of millions of degrees and emitting powerful X-rays, UV, and visible light, outshining entire star clusters. These active black holes, known as quasars, are among the brightest objects in the cosmos, detectable from over 10 billion light-years away. In 2019, the Event Horizon Telescope (EHT) captured the first image of a black hole, the supermassive giant at the heart of galaxy M87, weighing 6.5 billion solar masses. The dark shadow is the event horizon's projection, encircled by the glowing accretion disk. In 2022, EHT revealed our Milky Way's central black hole, Sagittarius *, confirming the prevalence of these monsters. General relativity also predicts black holes' hypothetical counterparts, white holes, which expel matter and energy, and wormholes, potential spacetime shortcuts, though neither has been observed, and their existence remains speculative. Planets, orbiting stars and shining by reflective light, are categorized by composition. Terrestrial planets rocky, like Earth and Mars, gas giants like Jupiter and Saturn, primarily hydrogen and helium, and ice giants like Uranus and Neptune, rich in water, ammonia, and methane. In our solar system, Jupiter reigns as the king of planets, with a mass 2.5 times that of all other planets combined. Its gravity ank is 95 known moons as of 2023 and acts as a planetary shield, deflecting or absorbing comets and asteroids, as seen in 1994 when comet Shoemaker-Levy 9 impacted Jupiter, sparing Earth from a potential catastrophe. Beyond our solar system, astronomers have discovered over 50 exoplanets using techniques like the transit and radial velocity methods. Some lie within the habitable zone of their stars, where liquid water could exist. Kepler 5 to be dubbed Earth's cousin, is 1.6 times Earth's size and orbits a sun-like star within this zone. Others include hot Jupiter's gas giants perilously close to their stars and lava worlds with molten surfaces. In 2023, TOI 145 to be a potentially water-covered planet 137 light-years away, emerged as a prime target in the search for life. Galaxies, the universe's building blocks, are vast systems of stars, gas, dust, and dark matter. Our Milky Way spans 100,000 light-years, hosting 400 billion stars, with our solar system nestled in the Orion Arm, 26,000 light-years from the center. Its structure includes spiral arms, a central bulge, and a halo rich in globular clusters and dark matter, the invisible substance that makes up 85% of the galaxy's mass, essential for holding it together. Galaxies are classified by shape: spirals like the Milky Way and Andromeda, ellipticals age stars, little new formation, and irregulars often small and distorted, like the Magellanic Clouds. They gather into groups, clusters, and superclusters. The Milky Way and Andromeda, along with about 50 other galaxies, form the local group, part of the Virgo supercluster spanning 110 million light-years. Galactic collisions are among the cosmos's grandest spectacles. In 3.75 billion years, the Milky Way and Andromeda will merge, their stars interweaving without direct impacts due to vast interstellar distances. The result, Milkdromeda, will be an elliptical galaxy. Hubble images of colliding galaxies, like the antennae, reveal stunning tidal tails and bursts of star formation. Other cosmic supporting actors play vital roles. Comets, dirty snowballs of ice and dust, develop brilliant tails, and near the Sun Halley's Comet being the most famous. Asteroids, concentrated in the main belt between Mars and Jupiter, include near-Earth objects, potential hazards, and Trojans orbiting Lagrange points. Some are rich in metals, future targets for space mining. The interstellar medium, though sparse, is the raw material for new stars. Nebulae like Orion, a stellar nursery 1,344 light-years away, showcase ongoing star birth, while interstellar dust reddens and dims distant starlight. From glowing stars to dense black holes, tiny asteroids to colossal galaxy clusters, these celestial bodies follow physical laws to evolve, collide, and merge, writing the history of the universe. Each offers clues to cosmic origins and fate. Stellar fusion explains elemental birth, galactic collisions reveal dynamic evolution, and black holes validate relativity. Humanity's journey from ancient stargazers to interstellar explorers continues to deepen our cosmic perspective, with countless mysteries awaiting the light of discovery.